Batteries are more of a part of our lives than they've ever been. Looking around, you can probably see multiple devices that use batteries. However, lithium ion batteries, like the ones in our phones, take a long time to charge, have a significant environmental impact, and have a limited life. Think of how often you replace your phone battery. This is where supercapacitors come in. Supercapacitors are like batteries in that they store energy. However, they have many key differences. A supercapacitor is like dropping and picking up a ball. You store energy in one by giving it a charge, and you can discharge that charge much quicker than a conventional battery. A battery is like rolling a ball across the table. The redox reactions taking place inside are much, much slower, and recharging and discharging them is also slow. Supercapacitors also have a much longer life cycle than that of lithium ion batteries, being able to charge thousands of times before losing the same capacity. They can also be used to smooth out fluctuations in current from renewable power sources. These factors make them useful for technology like quick charging batteries for smartphones, or you can even use them in electric and hybrid cars. One day, supercapacitors could become so prevalent that they replace batteries altogether. Batteries use slow redox reactions in order to generate current. The lithium starts in the anode, which is the negative side of the battery. In an oxidation reaction, the lithium becomes an ion in the electrolyte and detaches itself from the graphite crystal and heads towards the cathode, which is the positive end. Meanwhile, the lithium loses an electron to the wire that the battery is attached to. A reduction reaction then takes place in the cathode using the electron coming into the cathode. This causes the lithium ion to become trapped in the lithium-based crystal. This is what happens when the battery is discharged. When this type of battery is charged, the positive cathode is being oxidized, causing the lithium ions to flow through the electrolyte and become trapped in the anode crystal. In a supercapacitor, there are two electrodes on either end of an electrolyte solution. Supercapacitors work primarily on the principle of adsorption, which happens when the charged particles in the electrolyte stick to the electrode. The positive electrode attracts negative ions to it and absorbs them to their surface, while the opposite effect happens to the negative electrode. This stores a potential energy between the layers of the supercapacitor. This potential energy can then be released in the form of electricity. What really makes a supercapacitor is the use of pseudocapacitive materials like rubidium oxide and manganese oxide. Using these, we can create a capacitor with greater energy density due to the supercapacitor being able to carry out its own redox reactions. This process involves the adsorbed ions transferring charges between itself and the electrode of the supercapacitor. Unlike slow redox reactions, however, the material only clings to the surface of the electrode instead of becoming a solid attached to it. This redox reaction is unlike a conventional battery. Both batteries and supercapacitors can be made using heavy metals. These metals are toxic to both the environment and the animals that live in it, including ourselves. However, in 2013, researchers developed a supercapacitor that was made entirely out of environmentally friendly materials, like graphite. These supercapacitors are also easily disposable and burnable. This is unlike lithium-ion batteries, which must be disposed of carefully and at a high cost. Another advantage of supercapacitors is their aforementioned life cycle, lasting much, much longer than conventional batteries. The other advantage they have is their high use in renewable energy industry, helping power electric cars as well as store energy from solar panels and wind turbines. This is the reason why supercapacitors are the way of the future.